MS Ramaiah University of Applied Sciences.
Hello students. In this video, we will be discussing about the Brinell hardness test. At MSR UAS, the Brinell hardness test is performed on the same machine in which the Rockwell hardness test is conducted. The principle of Brinell hardness test is to press a hard spherical indenter with an exactly defined force on the test piece and evaluate the surface area of the indentation. Unlike Rockwell hardness test, the hardness number is calculated by a formula. The standards related to Brinell hardness test are ISO 65061-2005 and ASTM E10-14. The Brinell hardness number is indicated as HBW, W for the material of the indenter, tungsten, wolfram, carbide. For heat-treated plain carbon steel and medium carbon steel, the Brinell hardness number can be related to the ultimate tensile strength expressed in megapascals as follows. Ultimate tensile strength is equal to 3.4 times BHN. Most commonly, Brinell hardness test is used to test materials that have a structure that is too coarse or too rough to be tested using another test method. Example, castings and forgings. The indenter chosen for Brinell hardness test at MSR UAS is a 2.5 mm steel ball indenter. The overall load of 187.5 kg is chosen with the minor load remaining at 10 kg as in Rockwell hardness test. Non-ferrous metals, soft iron, steel casting, cast iron, malleable iron are tested under Brinell hardness testing procedure. The main parts of Brinell hardness testing machine are machine body having loads and levers inside, elevating handle, elevating screw rod with sleeve, work table for specimen, main shaft with indenter, indication dial gauge, load selector, handle for loading and unloading of weights, Brinell hardness standard scale. The cleaned test specimen is placed on the work table and gently brought in contact with the indenter. A preliminary or minor force, that is load, of 10 kg is applied. Automatically or manually, the penetration measuring instrument dial gauge is adjusted for 0. The major load of 177.5 kg is now applied gradually with the total load being 187.5 kg. Higher load is applied so that the resulting indentation averages out most surface and subsurface inconsistencies. After applying the major load for 15 seconds, the major load is gradually and gently released while retaining the preliminary load. This is carried out to allow for elastic recovery. The minor load is also released and the indentation diameter, smaller case d, is measured with the help of a Brinell microscope. The Brinell hardness number is calculated by using the formula BHN is equal to 2F divided by pi capital D minus square root of capital D square minus smaller case d square, where F is the force applied in kgs, capital D is the diameter of the indenter in millimeters, and the lowercase d is the diameter of the indentation expressed in millimeters. The standard format for specifying the Brinell hardness number is 55 HBW/10/300/15. where 10 kg is the minor load, 300 kg is the major load, and 15 is the dwell time in seconds.
Dear students, the name of the experiment is Brinell hardness testing, and the aim of the experiment is to find the Brinell hardness number for a particular specimen. The various things needed for conducting the Brinell hardness testing experiment are the machine, Brinell hardness testing machine consists of the main body which has the weights inside it, the elevating handle for moving the workpiece up and down, the sleeve on which the working table is available. On the working table we keep the specimen. The machine consists of the main shaft to which the indenter is fixed by the help of the Allen key. Next is the dial gauge. The dial gauge consists of an outer scale and an inner scale. The outer scale is the black C scale and the inner scale is the red B scale. In addition to the scales, there are two indicators here, one small and one big. For applying the minor load, both the indicators are used, and for the major load, the bigger indicator is used. The right hand side of the machine contains the dial gauge which we have to refer. This is the Brinell hardness test standard scale used. Please note that for a given type of material, the load to be applied is shown here and the indenter to be used is shown here. The material we are using here is brass, so we will choose 187.5 kgs and 2.5 mm ball indenter. Now on the other side of the machine we have the load selector and the levers. We will see that now. This is the load selector. Depending on the type of material for which the hardness is to be found, we can select loads. In this machine there are loads which we can select from 100, 150 and 187.5 kgs. Now we will move to the load selector. This lever helps us to apply load and remove the load. When we turn the lever to this side, we apply the load, and then when we take it back, we remove the applied load. The Brinell microscope. This is the Brinell microscope which is used to measure the indentation diameter. The indenter. This is a 2.5 mm ball indenter which we will be using for testing the specimen brass. The Allen key. For fixing the diamond indenter to the main shaft of the machine, we need to use the Allen key. And the specimen. This is the brass specimen for which we are now finding the Brinell hardness number. To conduct the experiment, we need to fix the indenter into the main shaft. The 2.5 mm diameter indenter is now inserted into the slot provided in the main shaft and is secured by the help of the Allen key. Now we will place the brass specimen on the work table of the machine. Now for the brass specimen, we need to choose a particular load by referring to the scale. The scale here says for the brass specimen we have to use 187.5 kgs as the total load. Now we will select the 187.5 kg load on the other side of the machine. I am now selecting 187.5 kg load. Now I am starting the experiment. The experiment is conducted initially by applying a minor load followed by a major load. After that the major load is removed and then we have to measure the indentation. Now by rotating the hand wheel, I am bringing the workpiece in contact with the indenter. Now the workpiece is in contact with the indenter. For applying the minor load, I continue to rotate the hand wheel. Please observe the dial gauge while I am rotating the hand wheel. The indicators on the dial gauge are moving. When the minor load is applied, the smaller dial, please note, the smaller indicator has coincided with 3 and the larger indicator has coincided with 0 in the red B scale. After applying the minor load, while I am applying the major load, the dial gauge moves. After the dial gauge indicates a particular reading, it stops at that reading. The dwell time is provided for ensuring elastic recovery. After 15 seconds for providing the dwell time, I am now removing the major load. After removing the major load, I am now removing the workpiece from the work table to measure the indentation with the help of the Brinell microscope. I am now explaining to you in detail the procedure to measure the indentation. As I told you earlier, the microscope has two scales, one the main microscopic scale, another is the thimble scale. When you view through the lens here, you will observe the microscopic scale. That microscope scale is indicated here. The microscope scale has 7 divisions which are further divided into 10 divisions each. 1 mm on the main scale is divided into 10 divisions on the microscope scale. Therefore, you will get 1 division on the microscope is equal to 0.1 mm. Now, to measure the indentation, the workpiece is kept below the microscope and the indentation here, indicated here in black circle, has to coincide with one end of the indentation has to coincide with one of the numbers of the microscope scale. Now, in this case, if you observe, the other end of the diameter of the indentation is between the 11th and 12th divisions of the microscope scale. Therefore, the initial reading is 11 into 0.1. Now, to get the balance of this reading here, we have to coincide the 11th division to the other end of the indentation. This is done with the help of the thimble scale. Initially, this thimble scale has to be adjusted to 0 before the measurement. Now, I have to move the thimble such that the 11th division comes and coincides at this point. One complete rotation of the thimble scale gives us 50 divisions. These 50 divisions, one rotation of the thimble scale moves by 0.5 in the microscopic scale. So, 2 complete rotation of the thimble scale moves to a distance of 0.1 mm in the main scale. Therefore, 1 division of the thimble scale is 0.01 mm. Now, to get the indentation diameter, we have to add the microscope scale value and the thimble scale value. You will get a diameter. That diameter is used to find the Brinell hardness number by applying a particular formula. Now, similarly, you have to conduct 3 experiments at various positions in the workpiece and follow the same procedure by measuring the indentation, find the diameter, later on apply the formula again, and you will get 3 Brinell hardness numbers. Find the average of these numbers to get the final Brinell hardness number, which is the Brinell hardness number of the material. This completes the experiment.
At MSR UAS, we spark your imagination unlike any other.